Hello and welcome to the first presentation for Untitled AIM training. My name is Lindsay Reynolds and I'm a riparian ecologist at the BLM National Operations Center. Today I'll be presenting an introduction to the Bureau of Land Management's National Assessment, Inventory, and Monitoring Program. What is the Bureau of Land Management? BLM is a federal government agency that manages natural resources across 245 million acres of surface land. Our mission is to sustain the health, diversity, and productivity of the public lands for the use and enjoyment of present and future generations. A little bit of history. The BLM was formed in 1946 by Harry Truman in a combination of two existing federal agencies, the General Land Office and the U.S. Grazing Service. Both agencies combined to create the BLM. The BLM manages 1 in every 10 acres of land in the United States. There are BLM managed lands and or minerals, subsurface minerals, in every single state, though surface land is more prevalent in the 11 western states and Alaska. The BLM exists within the Department of Interior. Here's a map of federal lands in the western US and Alaska. BLM lands are shown in gold and yellow here, and you can see they comprise a great portion of federal lands across the western US and in Alaska. BLM lands include diverse resources, and we manage our lands for multiple uses, including wildlife, recreation, livestock grazing, wild horse and burro, fire management, minerals and energy development, etc. The BLM Spatial Scales include several different levels, so I'm going to go over those here for a moment. Our largest scale is our headquarters office, which includes staff groups in Washington, D.C., and also across the West in Denver, Boise, Reno, and other locations. We also have a National Operations Center, or also known as the NOC, which is located in Denver and provides technical support for all of our offices. A step down from the national scale is our state offices. Then one step down from that are our district offices within states. And one step down from that are our most local scale field offices. And there are usually several of those within each district. So to understand those on a map, here's an example of some of our state boundaries. So our state management units are often one state, but they can also include more than one state. For example, our Montana state office includes both Montana and Dakotas, North and South Dakota. Our Wyoming state office includes both Wyoming and Nebraska. As you move down in scale, the next step down is the district, and there's usually 4 or 5 districts within a state area. For example, you can see in Idaho, there are 4 districts. And then inside each district are several field offices. Not to be confused with the field office building, a field office in BLM is an area of land management. It's our smallest, most local management unit, and there are usually 3 or 4 field office areas inside of a district. And then for each land management unit, there is usually an office associated with it. So for example, our state offices are shown here in black dots. There's usually 1 state office for each state management unit area. We also have district offices and field offices. Sometimes there are more than 1 management unit located in a given building. To understand how BLM manages land, it's important to go back to one of our foundational pieces of legislation, which is our Organic Act, the Federal Land Policy and Management Act of 1976, also known as FLPMA. FLPMA identifies several important foundational components of how we manage lands, including periodic and systematic inventory, including coordinated land use planning for each of our management units. It includes directing us to have goals and objectives based on multiple use and sustained yields of our land resources, and to prevent undue and unnecessary degradation. So this is where AIM comes in. What is AIM? AIM stands for Assessment, Inventory, and Monitoring, and is our monitoring program at the national scale, and is also has a written strategy. The history of AIM is that in 2004, the Office of Management and Budget, OMB, reviewed the BLM's monitoring budget and found that the BLM was unable to report on the national status of public lands with available data. So the BLM developed the AIM strategy to supply monitoring data that could be used at multiple scales. AIM is standardized monitoring. It's a standardized monitoring program for assessing natural resources on BLM public lands. AIM natural resource protocols include 3. Terrestrial, which includes rangelands, grasslands, and upland ecosystems. It includes a LODIC protocol, which covers stream and river ecosystems, and most recently added a lentic protocol, which monitors wetland and riparian ecosystems. The objective of the AIM strategy is to provide a standardized approach for measuring natural resource condition and trend on BLM public lands. It provides a quantitative data and tools to guide and justify policy actions, land uses, and adaptive management decisions. Part of the goal of AIM is to provide data to inform land management at multiple scales. For example, at the bottom of the list here is a smaller scale of management, such as restoration treatment effectiveness, which usually happens at pretty small scales. Our data can inform small scale restoration. And as you move up in terms of spatial scale, our data can provide information for recreation management, grazing permit renewals, for example, post-fire seedings at a more moderate spatial scale. And as you move up to larger and larger scales, resource managers might use our data to inform wild horse and burrow management or land use plan effectiveness. And then at a multi-state scale, our data helps inform range-wide sage grouse habitat management, which happens at multiple state scale. And then our data can inform national scale assessments such as national condition of rangelands. There are 5 principles of AIM. First, structured implementation, so thoughtful, integrated approach to monitoring. Second, standardized field measurements, what to measure and how to measure it. Third, appropriate sample designs, where and how to locate sample sites. Fourth, data management and stewardship, how to ensure data quality, availability, and usability. And fifth, integration with remote sensing, how to obtain spatially explicit resource information and integration of both our field collected data with large-scale remote sensed products. The first principle, structured implementation, is to guide monitoring program development, implementation, and management decisions. It includes guidance from the National AIM team. It includes training and standardized data collectors to provide comparable and consistent data. It includes informing data use to make management decisions. The second principle, standardized field measurements, is to allow data comparison throughout the BLM across our lands and in collaboration with BLM partners. Standardized field measurements are quantitative, our observers are calibrated, and it consistently measures land health indicators across ecosystems. And the methods that we use are also used by other national monitoring programs, so established with a solid foundation. The third principle, appropriate sample designs, is in order to minimize bias and maximize inference of our collected data. So at a landscape scale, we want to understand the condition of our resources. How do we do that on a landscape scale? We identify a study area, a large study area shown, for example, shown in a map on the right, and we do a random design where we draw randomly selected points on that landscape in order to draw inference for our resources on a landscape scale. The fourth principle, data management and stewardship, is to ensure data quality, accessibility, and use. So at a national scale, our data are standardized. We have standard QC, QA processes, and our data go, once their quality are ensured, they go into a national enterprise database that is accessible across the BLM with standardized calculated indicators. And our final principle, the fifth principle, is to integrate our field collected data with remote sense products in order to optimize sampling and calibrate continuous map products. So we use our goal is to use the latest, most cutting edge technology with remote sense products and integrate that with our field collected quantitative data to provide the most up-to-date information for each management decision and for applications with planning and understanding effectiveness. For example, here's a map of all AIM data. This map was current as of 2019. So in that year, we had a little over 60 wetlands and riparian sites, or lentic sites, shown in light blue. We had around 2,400 stream and river sites, or LODIC sites, shown in dark blue. And we had nearly 30,000 upland sites, or also known as terrestrial AIM sites, across the western US and in Alaska. So how are these data used? I have two examples of data use. In the first example, I'm showing on the left a map of the Vail District Office in Oregon. In this office, they were interested in using AIM data to understand sagebrush cover in priority habitat management areas for sage grouse in Oregon after several large fires. Their goal was to understand sagebrush cover in terms of a threshold. So if you look in the lower left, they were interested in this threshold of 15% sagebrush cover. And they found, looking at data across 675 plots located in their management areas across the district, that 39.6% of their plots did meet that 15% cover threshold, and approximately 60% of their plots did not meet that 15% threshold. So they were able to use data and in nearly 700 plots across the district to understand sagebrush cover for this important management question. My second example is up in Alaska, where sample design was developed to understand baseline conditions in the National Petroleum Reserve. This was a LODIC AIM project looking at stream and river condition. They collected data in dozens of sites across the NPRA in order to understand stream and river condition, baseline condition prior to oil and gas development, and therefore to understand potential future impacts. What is the role of the AIM data collector? To provide quality data. The AIM data collector is proficient in applying field methods. They understand how to implement a sample design to minimize bias, and they manage the data to ensure data quality. Again, our AIM program has three natural resources. We have terrestrial, which includes rangelands, grasslands, and upland ecosystems; LODIC, which includes streams and rivers; and lentic, which includes wetlands and riparian ecosystems. Our terrestrial and LODIC AIM programs were piloted in 2011 and 2012 and have collected thousands of sites across the western US for these two resources. Our third program was developed later and addresses the question, what about the wetland ecosystems where land and water meet? What about these wet spots on the landscape? That's how lentic AIM was developed and is the most recent addition to the AIM program. Lentic AIM collects monitoring data information on riparian and wetland areas and includes systems such as wetlands, wet meadows, marshes, seeps and springs, fens and bogs, vegetated drainage ways, oxbows, beaver complexes, floodplains, and the margins of lakes, ponds, and reservoirs. That concludes our presentation, introducing you to the BLM and the AIM program. And with that, we will transition to the next presentation of the lentic AIM training.